The zeta function is a harmonic series at s equals 1, so it has pole. And if s is a negative even number, it is a trivial zero. When s approaches 1, if x minus 1 is multiplied by the pole of the zeta function, the convergence equation of the zeta function is 1. The coefficient of the inversion of the zeta function becomes a pole when s equals 0, 1, and the sum of the zeta functions at s equals 0 is equal to the sum of the trivial zeros. So when s approaches 0, zeta function of 0 equals minus 1/2. The inversion of the zeta function is also consistent with the sum of the zeta functions of 70 terms to more than 10 decimal places. The identities of the inversion of the gamma function are always 1/2 and 1/4. And even if the left sum of the zeta functions becomes the trivial zeros, the right sum of the zeta functions includes the pole. Therefore, the product of the trivial zeros of the zeta function and the pole is 1/2, and the product of the trivial zeros of the odd zeta function, that is, the Dirichlet lambda function, and the pole is 1/4. Since the inversion of the L function, including the odd eta function, that is, the Dirichlet beta function, cannot but include the identity of the inversion of the gamma function, the identities of the non-trivial zeros of the L function are established under the condition of being real numbers by the identities of the non-trivial zeros that are conjugate to each other. The non-trivial zeros are located on the critical line, which is the same as the proof of the generalized Riemann hypothesis.